right, now, yeah, this is one problem that I don't think is going to need U substitution. It doesn't happen very often. We might as well note it. All right, so that's great. Now we might note that A is a constant. I mean, as per usual, A is always considered to be a constant, so we just make a note of that because you can see it's x to the A, which is a little intimidating because, whoa, we have x to a power that isn't known. How are we going to do this? And the answer is you can do it just fine. As a matter of fact, this problem is one of the easier ones from the examples here because you have two functions that are multiplied. Multiplication. And the inverse of multiplication, the integration of multiplication, involves integration by parts. So our technique is going to be integration by parts. And this particular problem only needs one technique. It only needs integration by parts. All right, so let's see if we all remember how to do integration by parts. You make a table. This will be u, this will be du, this will be dv, and this will be v. Remember, for integration by parts, for your choice of u, you want to follow the mnemonic Lipit. So logarithms, exponentials, polynomials, logarithms, inverse trig, polynomials, exponentials, trig. I just got distracted because I noticed, hey, there's a logarithm right there. So I think I know what u is going to be. U is going to be the natural log of x. Okay, so then du, actually let me kind of put this in, I don't know, some color or something. So this is the natural log of x. Of course, my orange got weird there because of my whiteout. So u is the natural log of x. I had to fix that. I couldn't let that stand. Then du is the derivative of that, which is 1 over x dx. Now dv would be x to the a dx, right? So x to the a dx, and v would be the integral of that. Well, remember a is a constant, so you just use the power property for integration. So you say, okay, x to the a plus 1, and then you multiply by the reciprocal of that new power. All right, so then integration by parts. We have the work kind of set up for us. So when we redo this, we want u v minus integral v du. Okay, u times v, that'd be the natural log of x times 1 over a plus 1, x to the a plus 1. So natural log of x, there's u, and then v is 1 over a plus 1, x to the a plus 1. There's u, there's v, minus integral v, which is 1 over a plus 1, times x to the a plus 1, du, which is multiplying by 1 over x dx. Right, so there's our v, and there's our du. All right, so then, let's see here. Over here, there's not much really to do because, you know, it just is what it is. So it's x to the a plus 1 over, times the natural log of x over a plus 1. That's all there is to say about that. You don't have any integration or anything to do there. Minus, okay, now the 1 over a plus 1 is a constant, so that can kind of come in front. So it's 1 over a plus 1. And then this is x to the a plus 1 over x. So let me rewrite that. X to the a plus 1 over x to the 1 dx. Okay, so this is the natural log of x times x to the a plus 1 over a plus 1 minus 1 over a plus 1 integral of x to the a. Right? Because if you subtract the powers, a plus 1 minus 1 would be x to the a. All right, well, this we can integrate. This is no problem. So this is the natural log of x times x to the a plus 1 over a plus 1 yet again, minus, all right, there was a 1 over a plus 1 there. And now when I integrate this particular piece, it'll be x to the a plus 1, and then there'll be another 1 over a plus 1 right there, plus c. Now I finally finish off my integration, so I'll put a plus c there. All right then, so you could say a plus 1 squared, but I noticed that both terms have an a plus 1 in them, and they actually both have an x to the a plus 1, right? If you see, they have an a plus 1 and an x to the a plus 1 right here. So I'm gonna, I shouldn't have probably written that as a diagonal, that's a little weird. So let me just kind of make it a horizontal line so you can see. So what I'm going to do is I'm going to take an x to the a plus 1 and an a plus 1 out of both of terms. In the first term, all that's left me with is a natural log of x plus, and then the second term, that leaves me a 1 over a plus 1. And you're done. Just a simple integration by parts.